When we described the parts of an atom, we talked about the protons and neutrons as being in a nucleus and the electrons as residing in shells around that nucleus. So here's a cutaway of a picture of an atom. But when we talk about these shells of electrons, what do we really mean, and where really is the electron around the nucleus? So to answer this question, we're going to have to put this picture together with the idea that an electron is a wave. And since the electron is a wave, that means that we have to describe it as a wave with a wave function. So our discussion of light waves thought about the light wave as a simple sine wave. And so this wave has a function. So I'm going to use the symbol psi for the function. The function for that wave is the sine of some constant times x, where x is the distance away from the origin. So that's a simple sine wave. And the electrons are also described by a wave function, which is periodic. That is, it repeats itself, just like a sine wave does. But these wave functions are more complicated than a simple sine wave. The complications arise because, first of all, they are three-dimensional. So rather than looking at the amplitude of the wave as just a function of the distance away from the origin, we have to think about the amplitude of that wave in 3 dimensions: distance away, what angle it is away from the origin, so x, y, and z components to that function. So it's a multi-dimensional function, so that makes it more complicated. Another complication that we run into is that in general, these wave functions are not real functions, they are complex functions. In other words, they exist on what we call the imaginary plane, and they involve the complex number I. So that makes it kind of complicated, and we have to think about how we're going to interpret these wave functions that describe the electrons. So the way that we interpret this is that if we take the square of the wave function, that will give us the probability for where the electron is in space. So for any x, y, and z coordinate, the square of the value of the wave function at that x, y, and z coordinate tells us something about how probable it is that the electron would be at that position. When we square a complex number, we always get a real number, and so this probability will always be a real number. So in general, what we tend to look at is not the wave function itself, but the square of the wave function. And we can draw three-dimensional figures that have the shapes and the sizes of those wave functions squared. And that's what this picture is here. This picture is the square of a particular wave function that describes where an electron is around the nucleus of an atom. One thing that you can notice about this three-dimensional picture for the square of the wave function is that there are places where there is no probability at all, so the wave function has a value of 0. That is the same as when this sine wave crosses 0. When it crosses 0, if you square 0, you still get 0. And so those points where there is a 0 probability are called nodes. A common misconception about these pictures is that each of these little parts of the wave square of the wave function represents a different electron. That's not true. This entire picture represents one electron. That one electron has a probability of being in close to the nucleus, but then there's a place where it will never be, and then it has a probability of being a larger distance away from the nucleus, and then there's a place where it will never be again, and then it has a probability of being even further away from the nucleus. So this picture corresponds to one electron, not more than one electron, just one electron, and that one electron has places where it has no probability of being. Just like this light wave has a zero amplitude, has no value, has zero at these particular places where this sine wave crosses zero. So we don't have any problem thinking about that for light, but when we think about electrons, since we're used to thinking of them as particles, it's hard to imagine that a particle actually just can't be somewhere. But we have to remember that that electron has to be described as a wave. And so just like this wave, it's going to have places in space where it has a zero amplitude or has no probability of being.